Today we will see how do we analyze logarithm function. Now, we have talked about logarithm for a while. We have talked about the definition, how do we expand or compress, how do we solve logarithm functions. So now we're going to see how a logarithm looks like whenever you graph it, and we're going to analyze that graph. So the main idea here is that we graph and analyze certain properties to have a better understanding about the behavior of the log function. So we're going to graph it and we're going to see certain behaviors and properties. So let's get started. Now here, this is the graph of a log function. Now the indication here is that we're given the following graph. Now let's analyze the following properties. So here, this is the graph of a logarithm function. You can see that it goes up kind of in a curvy shape. What this means is that as we go farther away in the x-axis, the y points, they increase, but notice that as we go farther and farther away, they increase at a lower rate. Here, the y's increase like so fast, that's why you have this almost vertical line. And then as we go to the right side, notice that the y's are still increasing, but they just increase at a lower rate. So now this is the main idea of a logarithm function. So now let's see. Let's analyze the following three properties. Now, the first property that we're really interested on is the domain. Here, domain is just another word to just say x values. If you see the word domain, they're just asking you for the x values. So here, they're just asking us, what is the domain of the function? That's the same as saying, what are the x values of the function? So let's see. Here's our graph. We can determine that by just looking at the graph. So the red is our graph. What do you notice about the x value? There's something important here. Notice that you do not have any negative x value here. So when we talk about logarithms, you will never have an x value that is negative. And you will never have an x value that is 0. So when we talk about logarithms, your domain is any other number greater than 0. So what is the domain of the function? The domain of the function is any number greater than 0. Can negative 1 be in the domain? No, because it's not greater than 0. Can negative 5 be on the domain? No, because it's negative 0. Can 0 be on the domain? It has to be greater than 0. Can 1 be in the domain? Well, look, 1 is right here, and it's part of the graph. So yeah, can 0.5 be part of the domain? 0.5 is about here. Yes, it's part of the graph. Now, if you want to use set notation, we can just say it's from 0 all the way to infinity. So this is the domain of the function. Any number that is greater than 0 is strictly greater than 0. It cannot be equal to 0 or less than 0. It has to be greater than 0. So now, let's describe the x-intercept of the graph. Now, what do I mean by the x-intercept? The x-intercept, well, let's try it in blue. The x-intercept from your geometry class in your Algebra 1, this is the x-intercept. This is the x-axis. Where is my graph touching the x-axis? Right about here. So that means that what is the x-intercept? The x-intercept of the graph is when x is equal to 1. It's basically saying, when is your graph touching the x-axis? Well, it's right here. And what is the x value? Well, that's equals to 1. Now let's describe the y-intercept. So let's erase the x-intercept for a while because it might get confusing. So now let's see. Here on the y, let's do this in orange. What is the y-intercept? Well, when is your graph touching the y-axis? So here's our graph. Notice that it keeps going down, 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 down. And it keeps going down, down, down. It's actually never going to touch the y-axis. That is one of the key properties of logarithms, that your graph does not touch the y-axis because the x values are greater than 0. So what is the y-intercept? It simply does not exist. Because when we talk about logarithm, the logarithm function does not have a y-intercept because the graph never touches the y-axis. Again, here what we're doing is we're graphing y equals log of x, and you will obtain this graph. This graph never touches the y-axis, so that means that we're never going to have a y-intercept. So these are three properties here. Domain is x value. The x-intercept is where it touches the y-axis, which we found to be 1. And for the log, it never reaches the y-axis, so it doesn't have a y-intercept. Lastly, let's look at three more properties here. Again, same graph. This graph is the graph of the function y equals log 10 of x. If you were to graph this in your graphing calculator, you would obtain the following graph. So now let's see. Let's look at the first property here. They're asking us what is the behavior as x arrow x infinity. So what does this mean? This whole x arrow infinity, this means that when x goes to infinity, that's what they mean by the arrow here. And this is the infinity sign. So here they're asking us what is the behavior as x goes to infinity or as x increases. Well, I mean, we have talked about this in the previous graph. Notice that here, as I move to the right, what's happening to my y values? Here we notice that if we move to the right, the y values are always going to be increasing. So what is the behavior as x goes to infinity? Well, the behavior here is that the graph, it's always going to be increasing. Let's do that again here. You start at the lowest x value that you can obtain. And as you move to the right side, your graph, it's always going to be increasing. It's always going to be increasing. But as you move farther to the right, it increases at a lower rate, but it's still increasing. So the behavior as x goes to infinity is as the y values increase. So now let's look at the second property here. So this is our answer. What happens when x goes to infinity? Well, we always look at the y values for our answer here. And that means that the y values are always going to increase as x goes to infinity. Now, here it says, what is the behavior as x goes to 0? This is the opposite of the above statement here. So now let's see. Pick any point. What happens as your x starts going towards 0? Remember that 0, it's on the left side. So let's start here. What happens to my y values as I'm getting closer and closer to x equals to 0? Is the opposite of the above statement. When x goes to infinity, y increases. So when x goes to 0, it does the opposite. Here, when x goes to 0, the y increases. Notice that I'm getting closer and closer to 0 here. And look at what happened to those y values. They're decreasing. So what is the behavior as x goes to 0? Well, here, the y values decrease. Now, here, let's try to describe the range. Range is just another fancy way to say y values. So domain is x and range is y. So here it's asking you what happens to those y values. Now notice that in x, you can only use positive x values here. And we established that on the previous slide. So now we're more concerned about the y values here now. So we're going to look at the upper and lower section. So let's see. If I'm increasing as x goes to the right, and I'm decreasing as x goes to the left. So is there ever some kind of bound when it comes to the y values? No, there's not, because here my graph is going to continue increasing. It's going to continue increasing, and it's going to continue increasing. Here it's going to continue decreasing. So there's no really bound on the y values because it decreases and then starts increasing. It basically is going to cover all the y values because it's going to come all the way down from the lowest y value that you want, and it's going to go all the way up to the highest y value that you can, which is going to be positive infinity. So what is the range of the function? So we say that the range is from negative infinity, whoops, to positive infinity. Because here, if it's just decreasing, then we're going to call this negative infinity. And if it's always going to be increasing here, then it's going to be positive infinity then. So it goes from negative infinity to positive infinity. And you can write this in set notation and just say from negative infinity to positive infinity. These are the properties that we're more concerned and that we really want to understand when it comes to logarithm functions. So now, here's your entrance ticket. In your own words, describe what domain is and describe what the range is.